This is fixed here, only this is movable. How will it move in all straight line? This one? No, not possible, no. So you look at the, you trace out this one. So this is a positive charge, this is a repulsive force is acting. Under the action of force and velocity, what is the possible path? Some curved path. Let this be question. Let me. So how the possible path of this one? So I'll start with this. So here in this particular position, so there's a position 1, I'll call it. The force F1 will act like this in this direction. The F1 will act along line joining them. So because of force and velocity, it should go trace the resultant path. The resultant path. So in what action it will, in what action the path will be traced. So it is going to. So will it move like this? No, it should deviate away from the velocity vector. No. It should deviate away from the velocity vector. So the path of that will be. So this will be the minimum separation. So when charge particle is here, it will have velocity v. I'll call this separation is minimum. You can call X or any other symbol. R minimum, I'll call it. You have to straight away ask one question, sir. How you can say at minimum separation, the velocity will be directed perpendicular to it. In any, you have to take care of the curvilinear motion. So I'll put, I think you recollect some concepts. So I'll write down the idea. The separation between the particles is minimum if relative velocity of the particles along the line joining them is 0. If relative velocity of particles along the line joining them. You go back to this, where you have come across this minimum separation, kinematics. There we didn't bother because we were more bothered about getting that minimum separation only. There's a one idea what you can in curvilinear motion, it has come across. At minimum separation between the particles or the relative velocity along the line joining the particles, it will be 0. The one very important condition. So that I'm going to apply. So definitely how the velocity vector will be now. It will be perpendicular to line joining them. That's why this perpendicular is what it's shown. So from where this idea is brought? From kinematics. Idea from kinematics. Okay, now, okay, fine. Somehow we brought it. How to bring that R minimum, no? That was our question. So one, we can apply conservation of mechanical energy. So from conservation of mechanical energy, initially, okay, what is unknown thing? This R minimum, no? So what I do is like, can I apply conservation of angular momentum? About what point? About O. You see what is the net torque? Net torque about O will be 0, no? So the net torque, the net torque about O is 0. Okay, there's a one equation. So based on that, applying conservation of angular momentum, LOI is equal to LOF, initial angular momentum, MV naught into D, final angular momentum, MV into R minimum. Okay, two equations are there, two unknowns are there, V and R minimum. So how to eliminate V? I'll apply conservation of mechanical energy. So from that, what should be the basic formula? Conservation of mechanical energy. So it should be equal to M V naught square by 2 plus K Q, call this is say some R naught is equal to M V square by R minimum.
So not R minimum, sir. 2.
Oh, wait. Okay, this is some. Oh, fine. This will be K Q by R minimum. Yeah. V and R minimum, two unknowns are there. So that can be determined here. I think some R naught, what to do with R naught? What to do with R naught? If R naught is far away, then interaction potential will be 0, no? So it all depends upon how you define. If the charge particle projected from far away, if R naught is, if point charge Q is projected from far away, then R naught will be 0, or else you should define this R naught, or you should give this particular distance. Then we can do this one. So let me just conclude. I think in books, so if the point charge is projected from far away from plus Q, then R naught what happen? R naught will become infinity. Almost it will become infinity. Then this quantity will become 0. Then the equation, or else you should give that L. So if you know L, then we can get the R naught, then we can solve it. There's the condition. So most of the books open, they have taken that to be at infinity, and they worked out, because in not mentioned, no. So I'll just putting this. Okay, fine. So these are some advantages of that energy method. You see, without energy method, try to analyze. It will be really, we can work out. We have to go for some curvilinear motion. Really very troublesome. So that everything what happen is just brought. So equation 1, this is 2, this is 3. If I just put a condition, something like R naught, no, far away something, no, so even that R naught will get eliminated. No need to calculate. So very simple.